receptacles located within 6 feet of Minnow tanks in a bait shop are required to have ground fault circuit interrupter, or GFCI protection. This requirement is primarily driven by safety considerations related to the proximity of electrical equipment to water. The fundamental principle behind GFCI protection is to rapidly detect and interrupt ground faults. A ground fault occurs when electrical current deviates from its intended path and flows to ground through an unintended conductor, such as a person. This can happen if there is a fault in the wiring of an appliance or electrical equipment near the water, like a Minnow tank. GFCIs are designed to monitor the current flowing in the hot and neutral conductors of a circuit. Under normal circumstances, these currents should be equal. If a difference of 5 mA or more is detected, the GFCI will trip, quickly cutting off the power to the circuit. This interruption happens in a fraction of a second, significantly reducing the risk of serious electrical shock. The specific requirement for GFCI protection near Minnow tanks stems from the increased risk of electrical shock in wet or damp locations. Water is a good conductor of electricity, so even a small amount of moisture can create a hazardous situation if there's an electrical fault. Because Minnow tanks are inherently wet environments, any electrical equipment used in their vicinity poses a potential shock hazard. The 6-foot distance is a standard safety margin used in electrical codes to define the area where the risk of contact with water is elevated. This distance is measured horizontally from the edge of the water source. Any receptacle located within this zone is considered to be in a potentially hazardous location and therefore requires GFCI protection. In the context of a bait shop, this requirement applies to any standard 120-volt receptacle that might be used to power equipment associated with the Minnow tanks, such as aerators, filters, or lighting. The GFCI protection can be provided either by a GFCI circuit breaker in the electrical panel that serves the receptacle or by a GFCI receptacle installed at the point of use. A GFCI receptacle has test and reset buttons on its face and can protect other standard receptacles downstream on the same circuit. When installing GFCI protection, it's essential to follow the manufacturer's instructions and local electrical codes. It's also crucial to test the GFCI regularly to ensure it's functioning properly. Most GFCI receptacles have a test button that simulates a ground fault. Pressing this button should cause the GFCI to trip, cutting off power to the receptacle. If the GFCI doesn't trip when the test button is pressed, it should be replaced immediately. It is important to understand that GFCI protection does not prevent all electrical shocks. It primarily protects against ground faults, which are the most common type of electrical hazard. It does not protect against shocks that occur when a person comes into contact with both the hot and neutral conductors of a circuit. However, by rapidly interrupting ground faults, GFCI protection significantly reduces the severity of electrical shocks and can save lives. In summary, the requirement for GFCI protection for receptacles near Minnow tanks in a bait shop is a critical safety measure designed to protect people from electrical shock in a potentially hazardous environment. It's essential to understand the principles behind GFCI protection and to ensure that it is properly installed and maintained. This is a vital part of electrical safety in any location where water and electricity are in close proximity. In addition to the safety benefits, compliance with electrical codes, including GFCI requirements, is also essential for legal and insurance reasons. Failure to comply with these codes can result in fines, penalties, and liability in the event of an accident. It is always best to consult with a qualified electrician to ensure that all electrical work is done safely and in accordance with local regulations. Furthermore, bear in mind that while I am providing a general overview of GFCI requirements, electrical codes and regulations can vary depending on the jurisdiction. Local codes may have additional or more stringent requirements than the National Electrical Code. It is crucial to consult with local electrical inspectors or a licensed electrician to determine the specific requirements that apply to a particular installation. It is also worth noting that GFCI protection is not limited to receptacles near Minnow tanks. It is also required in other locations where there is an increased risk of electrical shock, such as bathrooms, kitchens, laundry areas, and outdoor locations. The specific requirements for GFCI protection in these locations are outlined in the National Electrical Code and local electrical codes. The history of GFCI technology is rooted in the growing awareness of electrical safety and the need for devices that could quickly detect and interrupt ground faults. Before the widespread adoption of GFCIs, electrical shocks were a much more common and serious hazard. The development of GFCIs in the 1960s marked a significant step forward in electrical safety. The first GFCIs were bulky and expensive, but as technology advanced, they became smaller, more affordable, and more reliable. Today, GFCIs are widely used in homes, businesses, and industrial settings around the world. The ongoing evolution of GFCI technology continues to improve their performance and reliability. Modern GFCIs are more sensitive and can detect even smaller ground faults. They are also more resistant to nuisance tripping, which can occur due to electrical noise or other factors. As the understanding of electrical safety continues to evolve, it is likely that GFCI requirements will continue to be refined and expanded. New technologies and applications may also lead to the development of new types of ground fault protection devices. It is important to stay informed about the latest developments in electrical safety and to ensure that all electrical work is done in accordance with current codes and regulations. Electrical safety is a shared responsibility. By understanding the principles behind GFCI protection and other safety measures, everyone can help to prevent electrical accidents and protect themselves and others from harm. Remember, when working with electricity, always err on the side of caution. If you are not comfortable performing electrical work yourself, it is always best to hire a qualified electrician. This is not only the safest option, but it can also help to ensure that the work is done correctly and in accordance with local codes. In addition to GFCI protection, there are other important safety measures that can be taken to reduce the risk of electrical shock. These include using properly grounded equipment, avoiding the use of extension cords, and keeping electrical equipment away from water. It is also important to inspect electrical cords and equipment regularly for damage. Damaged cords and equipment should be repaired or replaced immediately. Electrical safety is a critical aspect of overall safety and should not be taken lightly. By understanding the hazards associated with electricity and taking appropriate safety measures, it is possible to prevent electrical accidents and create a safer environment for everyone. Information I have provided is intended for educational purposes only and should not be considered a substitute for professional electrical advice. Always consult with a qualified electrician before performing any electrical work.